All right, let's get into it. Today, we're going to go under the hood of a real-world, serverless AI sales agent. We're going to see exactly how it works, what makes it tick, and, maybe most importantly, how it's built to be incredibly cost-effective.
So, let's start with the big question, right? The core engineering challenge. How do you actually build a smart, conversational sales agent that lives on a platform everyone uses, like WhatsApp, and do it so efficiently that it basically costs pennies to run? And this isn't some pie-in-the-sky idea.
Okay, let's dive right in. We are looking at a real-world case study here, the fish farmer bot, built for a business called Serene. The whole thing is built on Node.js, running on AWS Lambda, with OpenAI providing the brains. Every single conversation kicks off with a WhatsApp webhook, which triggers this super lean, serverless machine into action.
To really get how all these pieces fit together, we've got to start with the blueprint. This is the high-level map of the entire system.
Now, what's really cool about this is how it breaks the whole system down into 4 clear zones. Right in the middle, you've got compute. That's our AWS Lambda function where all the logic lives. That talks to memory, which is DynamoDB. It's responsible for keeping track of the conversation and, the shopping cart. Then you have storage, which is just an S3 bucket holding the product catalog in a simple Excel file. And finally, the intelligence layer, which uses OpenAI for the chat and Fuse.js for some speedy local searching. Every single user request, every message travels through this exact path.
Okay, now for the fun part. Let's zoom right into that intelligence layer and the core logic that figures out what to do with every single message that comes in.
So, before any of the cool AI stuff happens, every message has to get past this entry gate. First, it checks for a valid token. That's basic security. But the really crucial part is the next step, deduplication. The system checks the message ID to make sure it hasn't seen it before. Why is this so important? Well, it prevents the bot from replying to its own messages, which would create these crazy, expensive, infinite loops. Nobody wants that.
Once a message is validated, it gets handed off to a function called detectMainTopic. You can think of this like a mail sorter at a post office. It scans the message for certain keywords, words like halal, delivery, or recipe. Based on what it finds, it sorts the message into a topic bucket, like certification or cooking. And this is a super important step, because the topic determines the bot's tone. For certification, it's going to be professional and to the point. For cooking tips, much more casual and friendly.
This right here is just brilliant, resilient design. If the bot figures out the user is asking a question, it kicks off this multi-layered, intelligent FAQ waterfall. It doesn't just bet on one method. First, it uses GPT to see if it's even a question. If it is, it tries to find an answer using a semantic vector search. If that doesn't find a good match, it falls back to a simpler, fuzzy search running locally. And if all of that fails, it doesn't just crash. It logs the question to S3 so it can be used for training later and politely tells the user it doesn't know.
Finding the right answer is only half the battle. The bot then does what's called personality injection. So you take a dry, factual statement like, "We have SFA certification," and you hand it over to GPT-4o Mini with a prompt that basically says, "Be a cheerful agent." The final output is friendly, it's got emojis, and a totally different vibe. The only exception, and this is smart, is for those formal topics like certification, where it deliberately skips this step to stay professional.
All right, so the bot can chat, that's cool, but how does it actually make a sale? Let's switch gears and look at how it powers the whole shopping experience, from the cart to the checkout.
This is absolutely key to understanding state management in a serverless world. Because AWS Lambda functions are stateless, they basically have amnesia and forget everything the second they finish running. The bot's memory has to live somewhere else. And that somewhere else is this DynamoDB schema. The state value keeps track of where the user is in the conversation, and pending order lines holds the shopping cart. This makes sure your cart is still there, even if the function has to do a cold start.
So how do you actually find stuff to buy? Well, you've got 2 paths, and they're both beautifully simple. Path A is your classic interactive menu with buttons. Path B is a fuzzy text search. So if you type something like Bara, Fuse.js is smart enough to match it to Barramundi. And get this, the entire product catalog, it's just an Excel spreadsheet. Seriously, it's just sitting in an S3 bucket, which is super low tech, but incredibly effective and dead simple for the business owner to update.
So here's how the cart logic works in this stateless world. When a user wants to add an item, the code checks that pending order lines array in DynamoDB. Is the item already in the cart? Yep. Okay, just bump up the quantity. Nope. Cool, let's add it as a new line item.
It's a simple if-else that lets you build your order piece by piece. Once you're ready to check out, the logic kicks in to crunch the numbers. It lists everything in your cart, calculates the subtotal, and then applies business rules, like adding a delivery fee if your order is below a certain amount. At the same time, there's a neat little state machine that lets you make last-minute changes, like adding special instructions or editing an item's quantity before you finalize everything. It's super flexible.
So, we've seen how everything works when things go right, the happy path. But what really makes a system robust is how it handles the unhappy paths. Let's look at the stuff working behind the scenes to make sure the bot is reliable and all the business data gets captured correctly.
I love this slide because it shows the system is designed to fail gracefully. It's thinking ahead about 3 common problems. First, high latency. If a response takes too long, it sends a quick thinking message, so the user doesn't get frustrated. Second, abandoned carts. If a user goes silent for 4 minutes, the session just gets cleared out automatically. And third, the unknown questions we saw earlier. Instead of failing, it logs them.
The system is also smart enough to know when to ask for help. If a user types something like help or agent, it triggers a human handoff. The bot sends a message to the user saying an agent will be in touch, and at the same time, it sends an alert to a real human admin. It's a critical safety net for when automation just isn't enough.
And here's how the bot actually plugs into the business operations. Every time an order is completed, it kicks off this simple 4-step data pipeline. The Lambda function downloads the master order log from S3, adds the new order to it, and then re-uploads the updated file. It's an elegant loop that gives the business a clean, always current record of all its sales, completely automatically.
All right, we have taken this entire system apart, piece by piece. So let's step back and pull out the key takeaways. What are the big design ideas holding this whole thing together?
So, in a nutshell, it's serverless and cost-efficient, thanks to AWS Lambda. It's context-aware, using DynamoDB so it doesn't have that amnesia problem. It's personality-driven, leveraging GPT-4o to transform raw data into a branded persona. It's business-integrated through that slick, automated Excel pipeline to S3. And finally, it's resilient with built-in fallbacks and error handling. We've basically turned a black box transparent.
Which brings us to our final question. Now that we've seen every gear and lever inside this thing, what does this kind of accessible, component-based, and super efficient serverless AI tell us about where automated conversational commerce is actually headed? That's definitely something to think about.